let's take a look at angle 1 in this diagram. If I trace it out to see the sides a little bit better, I can see that it's still an inscribed angle. Recall that our definition of an inscribed angle from a previous video was an angle whose vertex is on the circle. So even though this doesn't look exactly the same as those angles we looked at in the other video, it's still an inscribed angle, so it still meets the same criteria, meaning the measure of that angle is going to be half of the arc it intercepts. So we kind of talk about these in a different section, although I think it's kind of silly. It's the same exact thing as we just did. If I look at angle 2, it's also still an inscribed angle. It doesn't look exactly like the angles we talked about before with inscribed angles, but its vertex is still on the circle, so it's still an inscribed angle. So taking a look down here, we can use that fact to find the measures of missing angles and missing arcs. So angle 1 is what we want to find. It is an inscribed angle. Its vertex is on the circle, so its measure is going to be half of the arc it intercepts. Remember, the arc is always going to be the bigger of the two numbers if you forget which way to go, half it or double it. So half of 130 degrees gets me a 65-degree angle for angle 1. And if I take a look over here, this time they asked me to find the measure of the arc, so that's the one out here. Once again, I do have an inscribed angle, even though it doesn't quite look like one. It's still an inscribed angle. Its vertex is right there on the circle. So since the angle is 125 degrees, I double it to find the arc it cuts off. So that arc is going to be 250 degrees.